All right, so let's carry on. We're down here to firewalls. So the earliest firewall was what we now just call a packet filter. This would just look at the header in a packet and make a decision whether to forward it or not based on what's in the header, like the port number and the direction of traffic. So that was better than nothing, but it turned out to be pretty easy to dodge. So for example, here you'd allow all the ICMP replies to go out because you don't have the intelligence to know whether the ICMP reply is part of an established stream of traffic. So the better one, which is what you have on a modern Windows machine, is a stateful firewall, where it has not only the header information in the packets, but it has a state table so it knows if there is an established connection. And so here, it will block an echo reply if there was not a preceding echo request to create the situation where you'd expect it to come through, and the same thing with TCP. So that's a stateful firewall, and this is what you have on Windows laptops, so that if you go to a coffee house and you have file sharing turned on, your firewall will be set to a public network and it will not accept file sharing connections from the outside. It will let you go to any website you want and then receive a response from that website, but it will throw away any unexpected incoming traffic, which means that your machine runs as a client and cannot run as a server, which is the way you normally want it in a public network. And that's a stateful firewall. Then there are proxy firewalls that not only decide which traffic to pass through, but if they do let something through, they readdress it so that it has a different from address, so the external device cannot even see your IP address. Everything has to make a complete connection to the firewall, and then the firewall resends it to you. That's what a proxy does, so it hides the details of the internal network. Application layer proxies can filter at higher levels, like block URLs, to remove known bad websites, and they're often specialized to certain protocols. Circuit level proxies operate at layer 5. SOX is the only one I ever see used in its level. Tor is a SOX proxy, the Tor privacy network. So it forwards your packets over a higher level protocol. It could in principle even forward things other than IP, and so you can it's just another way to move your traffic onto a different network, and the point is it can conceal the source of origin if you use a proxy forwarding system like Tor. A Bastion Host is a really old idea that was around before modern firewalls. Isn't Tor dark web? Well, Tor can be used for the dark web. Tor conceals the source of you, so nobody knows your IP address or your physical location, and the same thing's true of a server. So you can put up servers on Tor that are serving illegal content, and the Tor makes it difficult for people to find them physically. So yes, Tor does let you get onto the dark web. You can use Tor and go to normal legitimate websites though, and if you do, it will make your traffic more private. It will also be slower. But yes, that's the main thing about Tor. Does proxy change like a subscription? Yes, some proxies do charge. You can purchase proxy services. That's essentially what a VPN is. And you can also get reverse proxies like CloudFront on Amazon, which is a proxy to protect your servers. They can be software or hardware, but most everything is nowadays software running in virtual machines. Those are good questions. So Bastion Host was the really old solution. Before people had firewalls, you'd have a special host just to be the gateway and route the traffic. And I noticed that Microsoft now offers this on Azure. You're not supposed to have an open RDP port on Azure directly to the internet, and Microsoft has the ability to turn on a Bastion Host, which is sort of a virtual machine in front of your Azure cloud machines to prevent them from being directly connected to the internet. There were dual home hosts is another thing. We just have a host between two networks, and you have to log into this to get into there. This is, again, an old solution, probably not implemented this way anymore, now implemented with modern firewalls. Screened hosts are where you have a screening router. All the internet traffic goes first to the Bastion host, and then the Bastion host will decide whether you're authorized to get in further. But this one here, in this setup, if the Bastion host failed, it would fail open and let your traffic through unprotected. Yeah, Tor requires exit nodes. you can run an exit node yourself. I did it for a while. If you do, you will immediately get flooded with DMCA takedown notices. And if you look at the traffic exiting the exit node, you will find that it is 99% horrible stuff, like child pornography and malware. And that's why even MIT shut down their Tor exit node. You have to have a real strong stomach to run a Tor exit node. You have to be very, very zealous about anonymity and freedom to where you're willing to contribute to, say, 100 crimes for every good person trying to hide. So Tor is not for the faint of heart. And it's mostly run by the U.S. military. If you're inside Tor, it's very hard for anyone to know what the content is. That's why if you put a server up in Tor and the dark web, nobody can find it because you just have this long random URL. There's no way to scan for them, so you have to advertise it. If you don't advertise it, then nobody will ever find it. So you have to put it on a forum. That's what you do. You put up a dark web marketplace selling something illegal, and then you go to forums and you post, go to this URL to get there. That's how you get your customers. That's typically how it's done. Yeah, it's all done with layers of encryption. Yes, and you will get DMCA takedown notices because tons of people are downloading copyrighted stuff over Tor, but there's also a lot of malware and a lot of criminal stuff. So it's mostly nasty stuff, but the purpose of it is so that American spies can report from nations, and therefore people that are protesting in nations can hide their identity with it. And that's why the U.S. Navy set it up, or U.S. military set it up. The point is they let all the idiots in the world download porn through it, and they provide cover for spies to send their spy data back. Exactly, yeah. Yeah. All right, so that's the screened host. And then there's a DMZ, which is the way a lot of people do it these days. So you have one firewall from the internet, which blocks the obviously terrible stuff, and then you have your public servers, which everybody can get to, and then you have another firewall which has more strict rules, such as typically you have to prove that you're actually a company employee, and then you get in the trusted network here. So you have layers of security. This is defense in depth. You have one defense blocking certain problems, and you have another layer of defense behind it before you get to high privilege stuff. And of course, this is the first step towards what we're all supposed to be going to now called zero trust, where your whole network is supposed to have test everything. Every request you're supposed to test to see if it appears to be malicious all the way through. So you sort of extend this to many layers. So you can do this with one firewall too. You can have a firewall that has one set of rules to get to this network and a more strict set of rules to get to this network. It doesn't require two hardware firewalls. Just one modern one can do it. Okay, and a modem is how you connect to the old dial-up phone line, or now these days to DSL line. So it takes your binary data from your computer and turns it into analog signals that can travel through an analog phone line. DTE, DCE are things you use to make a serial port connection to an ISP. You wouldn't use it on a local area network. And the DMARC is where you get to. There's a DMARC at your building where the external ISP data network stops, and then inside is your responsibility. So that's the point where your ISP considers itself to have provided service to you if it gets to the DMARC, which is typically a box on the wall in your garage, and then inside from that point to your computers is your responsibility. So the CSU DSU is is the type of circuit carried by this, which is a clocked signal, sending data to the internet service provider, and that's what you'd get if you're purchasing like a T1 line or something. So if you want to do secure communications, there's authentication protocols, virtual private networks, and remote access. These are common types of secure communications you need to have. So first thing is, how do you prove who you are? And that's authentication protocols. In the early days, you used PAP, which would just send your password over the network in plain text like Telnet. This is, of course, terrible because anybody can sniff the traffic and find your password. So this is totally out of date and nobody should be using it anymore. The next step up was challenge handshake. The server would send you a challenge, some random letters. You would add that to your password and hash the result and send the hash back. And therefore, the thing you sent over the wire is calculated from your password, but it doesn't directly contain your password in plain text. So this doesn't expose your password as much. 8021X is the protocol that lets you have port-based network access control. And so you have an authentication server and an authenticator. And it looks like this. You connect to the network, to the authenticator, and the authenticator collects from you, say, a username and password or whatever you're using, like biometrics or something. And then it goes to the authentication server, which has the records of what all the authorized users should have, and it decides whether you have, in fact, satisfied the authentication conditions. And if you have, it then grants you to the internal network. So that's how 8021X works. And you can use a variety of cryptographic protocols for these authentication steps. So one of them was an old one based on MD5, which is, of course, an old hashing algorithm that's not considered secure and not recommended anymore. Cisco invented a protocol called LEAP, which was intended to improve WEP encryption on wireless networks, but it turned out to be not very good and not very secure, so it's not recommended anymore. Then there's EAP-FAST, which is what Cisco developed to fix it, and that's considered quite good. And this uses a pre-shared key. TLS is another way that uses the same translation layer security that you'd use for HTTPS connections, and that is modern and very strong as long as you've updated your certificates to the modern recommended key lengths. And this one required certificates on both sides, which is clumsy to set up. RSA key, there is an RSA key included in TLS, although most of these days it's really done with elliptic curves instead. But TLS includes RSA keys at both ends in its original formulation. And then there's EAP-TTLS, which allows your client to use a password instead of a certificate, so it's easier to deploy, and this is more like your normal internet situation. And anytime you're using TLS, it could be using RSA. It was all originally intended to use RSA, but most modern implementations have switched to elliptic curves instead, just because they're faster and cheaper. And then there's PEEP, another similar system, which is also modern and reasonably secure. So there's 4i. How granular does it get down to the details? You know, I don't see that many. When I took it, although it's a few, it wasn't all that picky, you know, but I don't remember any questions quite this deep where you'd have to know the difference between these different protocols, but there probably will be a few. Yeah, it's a good question, and I don't know the best answer. The best answer is get a good practice test. And I mentioned before, get a modern practice test and do that. That is the only way you'll have a good clue of exactly how deep you have to get on this stuff. But you certainly don't get very neat. All you really do is recognize the terms and know, like, whether they're recommended or not anymore. Because remember, you're a manager. you're not into the bits and details. You're just into, when you read a description of a product, you should know whether it's a good product or not. That's essentially the level you want. But the other thing is, of course, the main problem with the practice test is, the main reason you need it is because the questions are written in a very strange, confusing way, and you have to get used to that. Yep. All right. All right, so what firewall uses only the header information in the packets? Yeah, that's a packet filter, the simplest, oldest firewall. All right, which one runs at OSI layer 5? SOCs, yep, like Tor. All right. All right, which one provides port-based network access control? All right, that's 8021X. And which one is vulnerable and should not be used? LEAP, lightweight, extensible authentication protocol, is old and not good. All right. All right. All right. Good. All right. And now there were questions about the practice test. So let me just answer that one before we do the last bit of the lecture, because that's important. There is one practice test that I highly recommend. It used to be called Transcender, and now it's got a different name. And let me find my link, because I remember I updated this link a few weeks ago to say the right thing. So let me find it in case anybody doesn't remember that, because you definitely need a practice test. You cannot just go by knowing what's in the book. You have to practice answering these strange CISSP questions. So I put it here among other places. I updated this thing, which is how I prepared to refer to the correct name. Cyber Vista, there it is. Transcender has changed its name to Cyber Vista. This is the one. It's expensive and absolutely the best one to get. It cost like 125 or 150 bucks when I got it, and it's probably even more now, but you definitely want to do it. This is how you prepare. They are not stolen questions, but they're at the right level. And if you practice this thing as recommended until you're getting 100% on those tests, then you really will pass it easily. That's how I did it. And I think they do have some kind of bundle where you can get multiple tests from these guys. They have tests for everything. They have practice tests for everything else, like Security Plus and Net Plus and Cisco and Microsoft and all that too. So it's these are very good. I highly recommend them. Don't waste your time with cheaper products. Yes, exactly right. Some questions have more than one answer, and also some of them, all the answers are kind of wrong, and you have to choose the best among them anyway. That's the thing. The CISSP is notorious for being very misleading and confusing. You have to get used to those strange questions. Other things, like Cisco and Microsoft and CompTIA exams are more like ordinary college exams where there's just a question and there's one right answer and all the rest are wrong. CISSP is not that way. Good. An important topic. I'm glad people are planning to get your CISSP. It's good for you, of course. All right, so VPNs. Very popular these days, of course. I hear them advertised everywhere. So the point of a VPN is to have a point-to-point connection between two devices that is as if they had their own private line that nobody else was sharing with them, but you're really going over shared lines on the internet, so you use encryption to garble your traffic so hopefully nobody else can mess with it. Well, yes, all exams are you have to choose the best available answer, but I think in the Cisco exams, it's not like all the answers are stupid. Anyway, but you always do have to choose the best of the available answers. All right, so SLIP was an early way to make connections over the internet. This did not encrypt anything, though. It would just make your data get delivered to the other end, but that's no confidentiality, integrity, or authentication. PPP added these things, point-to-point protocol. PPTP was very popular encryption protocol. It's come built in by default in all Windows machines for decades. It's easy to set up, but the problem is it's kind of old and it's not very safe anymore. There are ways to hack it. So it's an old, not recommended VPN protocol, but people still do use it pretty often because it's very easy to set up. L2TP is a tunneling protocol that delivers traffic carried over another network, but it does not encrypt anything. So by itself, it just provides availability, but it doesn't provide confidentiality. However, you can combine L2TP with IPsec, and if you do that, you have a strong recommended modern VPN. This is considered a good one. Use IPsec for the encryption and L2TP to deliver it, and the two together are considered a strong VPN. IPsec can take your host to a gateway or a gateway to a gateway for like two locations of a company or host to host. You can configure it various ways. And so it's got transport mode where you take the data, but you keep the old IP header, or tunnel mode where you track the entire IP packet in another IP packet. In practice, there's not much difference. But anyway, both modes exist. And then, of course, there's SSL and TLS. SSL was the original Netscape encryption protocol developed to encrypt internet traffic, but it's now all obsolete. Now everybody should be using TLS, and they go over port 443, and you can make a virtual private network go over TLS just like your HTTPS traffic, and of course that's very easy for people to use. All right, and then there's remote access. You want to remotely control a server, like a cloud server, for example. So there were various ways to do this. One old technique was to have ISDN lines, which is another point-to-point line. This was really old. You have 264 kilobits per second channels like dial-up modems, or 23 of them. So these are ridiculous. I don't know anybody in America uses ISDN anymore. Then there's DSL, which is, of course, a lot of people using this because these are nice and fast. Or you're sending data over an analog phone line with an advanced modem that encodes the data with all kinds of very subtle deformations of the waveform, so it can actually move a lot of data. And so if you're close to the phone switching station, because you're in a city, you can get up to 50 megabits per second or even more. Cable modems, of course, move your data over the coaxial cable that carries cable TV, and that can also be very fast. That's what I'm using right now. Again, you can only get it if you're in the cities where they have cables for cable TV. All right. You can use an authentication system where it just calls you back at your known phone. This would make sense if everybody would just stay at home like they have been lately due to COVID, but if they're on the road, this is not such a good idea. Caller ID is another thing you could do to verify that the person calling in is who you think they are, but the problem is caller ID is not authenticated. You can spoof a caller ID. This is done all the time. So this is, again, not a very secure way to make sure that these people are really authorized people coming in. Remote desktop and console access. There used to be some protocols, rlogin and RSH, which would let you go from one Unix system to another, but they sent passwords unencrypted over the internet, so they're no longer recommended. Modern remote access protocols that give you graphics are VNC and RDP. VNC is commonly used for Linux desktops and sometimes for Windows desktops, but they mostly use Microsoft's remote desktop protocol, which is a licensed version of Citrix, and that gives you a graphic image of the desktop on a remote server so you can control it with your mouse. Go to My PC and Log Me In are another one that gives you control of a machine remotely. Virtual desktop infrastructure is another way to do it, where you have a desktop image running on a server and deploy it to a workforce. Then there's application virtualization like Office 365, where your software is actually running on a server somewhere. It's not running on your local device. This is great because your local device can be weak or out of date, like an iPad or something, and you can still do the job. So it also means your company can always make sure they update the version on the server and everything, so you can have a patch management, you can limit who gets in, and the data is never even leaving the server, being stored on your local device. It's just staying on the server. So that's very popular in this work from home environment that we're all living in. Screen scraping is one way to take data from the graphical desktop and send it across. Yeah, virtual, thank you, good. Anyway, that's what VNC does. RDP is different. Anyway, instant messaging. To talk to people is real-time chat. The early one was IRC for Unix servers to talk to other Unix servers. Some people are still using it, but most IRC traffic is now malware and nasty stuff. AOL was an instant messenger people used a lot. I don't know if people are using it still. ICQ is another one that's been around since the 90s. These use a protocol. There's XMPP for chat. These things, the old ones were not very safe. They had buffer overflows and the usual sort of flaws, and you can use them to transfer files, and that might violate your security policy. There's remote meetings, of course. We're all living on Zoom and such. So GoToMeeting by Citrix is one. Microsoft Office Live Meeting has now been replaced by Microsoft Teams. But you all know what this is, and there's Zoom and such, so you can share images and video and files and everything here. And again, you might violate security policy here. I've heard of situations where people have supposedly air-gapped computers, and yet you can make outgoing Zoom calls. So in fact, there are ways to sort of bypass the so-called air gap. So, these can be another hole in your security policy. How a chat room can be hacked. Oh, sure, that used to be all the rage. I used to use Yahoo Chat years ago. You just send a string of special characters, and it would be misinterpreted and have like command injection vulnerabilities. All those web vulnerabilities are there. So you would just send an unusual message, and when it was rendered to appear on somebody's screen, it would hack through their chat client and, have an unexpected result, like change their name or crash their machine or crash their chat client or something. Boots are how it all started. You would learn how to put up a message which would cause the chat client to crash, and that would kick people out of a room. So there were a lot of those. It was a big problem back when I used to use Yahoo Chat. There were these hackers that would come in and trash your stuff. BBS was super secure. I don't know what BBS was. Oh, BBS, right? BBS, that was the really old one, where you would make an analog phone call with a modem to one person. Only one person at a time would go in there. So I don't know if it's super secure, but certainly you never have a shared network really. So yeah, BBS. Those are still around, I guess. Yeah, old bulletin board systems. Yeah, but I think some people are still using them, but not that much anymore. But certainly they're secure against most attacks because you only have one user at a time. Anyway, so then at one time there were these PDA things like the Palm Pilot. Those things I think are extinct. Now everybody gets smartphones instead. And of course, the smartphones and the PDA and your laptops and your iPads, all these things have the problem that people keep losing them, and then they've got your company data on them. So you really ought to have remote wipe, and you ought to have security agents on it so you can make sure it's encrypted and stuff. And really, it'd be a lot better to just have a virtual desktop infrastructure so the data is not even on that remote device. But it is, of course, an issue. If you're going to have a portable device people are carrying around, then obviously they're going to lose it and get it stolen, and you have to be prepared for that. Wireless security, you should use secure connections like WPA2. And if you're using Bluetooth, be aware there's a lot of Bluetooth security issues. There's a thing called Wireless Application Protocol based on TLS that lets you can provide secure web services to handheld devices. But I think this has disappeared and is out of date. Like several things mentioned in your book, I don't think they're relevant anymore. And then, of course, content delivery networks. These are very popular. Cloudflare and Akamai are the big ones because if you have a server and you become popular and people over the whole world are using your server, you don't want people in Australia having a 100 millisecond delay to get to your server in California. You want them to have a local copy near where they live so they can get a fast response and you don't have to handle all the bandwidth at one place. So you have caching servers all over the world, and these are very popular. Almost everybody's using these. When you connect to any big website like Google or Amazon or Microsoft, you're not connecting directly to their home base. You're connecting to a copy of that page on a local server near you. Same thing is true of my website. I use Cloudflare. So when you go to my website, you're in fact looking at a copy of it stored near you. All right. 4J is the last one, which is here. Yeah, that's decentralizing your stuff, yeah. Well, maybe that's all we're going to get. Aha! Even less. I'll wait a few seconds to see if number 9 comes back. Aha! Okay, let's go ahead. All right, so which one gives you transport but no encryption? Okay, that's Layer 2 tunneling protocol. It tunnels through the internet, but does not encrypt the data. All right, which one of these is not safe? PPTP. Easy to set up, but out of date and not safe. Right, which one runs over 3389? Yeah, good old RDP, a dangerous technique. You know, like say Microsoft Azure will warn you not to connect it directly to the internet. RDP servers keep getting hacked all the time. All right, and which IM system has been around since the 80s? IRC is the really old one, goes all the way back. All right. Well, Hammy has been winning a lot of these. All right.